Let's say you have this bag. This bag is magical and can hold an infinite amount of stuff. However, you are not infinitely strong, so you can only hold so much weight. There are a bunch of items you can take on your trip, but you can't take all of them. You have assigned a value to each of the things you wish to take. What combination will give you the greatest value? This is known as the knapsack problem. Initially, you could say, we should take Gates because she doesn't weigh very much compared to her value.
I feel loved by how much you value me, though I'm not feeling so loved by your stuffing me in a bag.
Also, we should not take the elephant. She's not that valuable and weighs a lot.
Rude.
But we are looking for an algorithm for future ease. One thing we could use is recursion. However, that is a big O of 2 to the n factorial, which is one of the worst kinds. I bet we could get this down to a big O of n times b problem, where n is the number of items and b is the bag capacity. For this dynamic programming approach, we will store each subset that we have already looked at in a matrix instead of recalculating each time we use it.
Yay, matrices! However, I'm still in a bag, and I don't like that.
And I suppose we can demonstrate this problem without putting living things in a bag. The column on the left shows which items we are currently considering. The top row asks what would be best for that weight up to the total weight that we will carry. First, we will put zeros in the second row because we have yet to consider any items. We will also fill the second column with zeros because if we are flimsy and can't carry anything, we can't carry any value. Next, we will consider just taking the saddle. There are only two options regarding the saddle. We can either take it or not take it. We can't take just part of it because what would you do with half a saddle other than fall off the horse? If we could only take 1 unit worth of stuff, and this 7 weight item is the only thing we consider, then we get 0 value. The same goes for if we can only carry 2 to 6 weight. Now we consider if we carry 7 weight. Lucky for us, we have just the thing. This will give us a value of 5, so we put that into the matrix. We only have 1 saddle, so the rest of this row will be 5s as well. The next object is output. We are now asking what would be the best at each weight if we only had these 2 items. Until we have 5 weight, we will just take whatever is in the box above. If we can carry 5 weight, we can now consider output. We will take the best option between the box above it and its value, plus current capacity weight minus this item's weight from the row above it. Because 3 is the bigger of the 2, we put that in the box. Let's skip ahead to where there is more going on. Now for the poppy. For the first box, we can carry a weight of 1. This means we could take the poppy if we wanted to. We will try to get the max of the 2 possibilities, which are taking it or not taking it. If we don't take it, we will just look at the box above it, because that was the best we could do with weight 1 without the poppy. The other option is if we take it. If we do, that will give us a value of 1. Additionally, we will take our best option for the total weight minus the weight of the poppy. Then we look at our previously best answer given the weight of 0. Next, we have a weight of 2. We do the same with the next box where we take the max with or without the poppy. There are many variations to this problem. Like, what if I had an unlimited supply of each item? What if there is diminishing value for duplicates? because what am I going to do with 15 copies of my notes? What if the more I carry, the less cool I look, and I also want to maximize my coolness? Finally, we can see that the best value we can get with a capacity of 12 weight is a value of 22. If we want to figure out what we should put in the bag, we can start by comparing the bottom right box to the box above it. Because it's different, we know that the knife goes in the bag. We consider the weight of the knife and go back that many boxes from the box above it. We then compare this new box to what is above it. Because it's different, we know the poppy also goes in the bag. We go the poppy's weight back and compare this box to the one above it. Because these boxes are the same, we know that the flag is not in the bag. We'll skip over this one by going straight up. We continue this pattern until we know what goes in.
Thank you for not shoving me in the bag this time.